Et donc, bonjour à tout le monde. Et alors, on commence.
Hello everyone. Welcome to this second session in our Demystifying Data workshop series. We had our first meeting 2 weeks ago. This is our second meeting. We'll finish around 1:15. It's a roundtable discussion with 4 participants. Next, we'll take a 15-minute break, and then at 1:30, we will hold a workshop on modeling of data. And we will look at it through a social sciences and humanities lens with Mr. Trépanier, who is here with us today. He will lead the workshop. It will also last about an hour and a half. And so we'll finish around 3 o'clock. So let me get started. First of all, I'll present our speakers quickly. So we've got Professor Lyne Da Sylva with us, full professor of information science at the University of Montreal and director of the Information Sciences and Economics School. She's published several articles. One of them was recently published, and I did my doctorate in the same topic as this article, so I found it very fascinating. I read a little bit about it. I can't wait to go read the whole thing. It's been published recently. Next, Jean-François Chartier, data scientist and researcher at Beneva. He got his doctorate at UQAM in communication sciences. He's published several papers on automated treatment and processing of language. Next, we've got Félix Fortin, who is acting head of the production and outreach unit at StatsCan. He's an expert in data processing and preparation, and today he will be able to talk to us about his experience at an institution such as StatsCan that works with data a lot. So it'll be very interesting to hear what he has to say. Madame Hélène Vidot-Delerue is a professor at the Management School of UQAM and project management chair. And of course, she has many publications, and she will bring a qualitative analysis approach to the discussion today. She's got a lot of experience in this field. So, Madame Hélène Delerue, could you just say something? Do you hear us well? Yes? You can hear? Okay, great. Well, then I will let the speakers take over. I will take questions from the room. I've also got questions that we've prepared, and I'll take questions from Zoom. So that's it. I've already got some questions that I'll start with to guide our discussion today. So let's get started with the roundtable discussion. And our first question, it's kind of an open-ended question. In data analysis, it is said that 80% of time and resources are spent on data preparation. In your experience, what is the biggest challenge you have encountered in data preparation? So whether we're talking about data gathering or cleaning. The biggest challenge, well, it depends actually on the type of data collection we're doing, secondary versus primary. Primary, it depends on the response rate. The response rate is the biggest challenge because if we want to have qualitative data, quantitative data, in both cases, we have this problem. Interviews, surveys, etc. We want to have a good sample size. Now, regarding secondary data, this brings us to a different problem, data cleaning. When I say data cleaning, I'm talking about checking if there's missing data, if there is data that has been entered incorrectly, because sometimes we see this in databases, all those kinds of factors. This all takes time because the research results can be completely changed depending on how you do this. So with primary data, if the response rate is insufficient, and if the sample is not representative of the population that you're targeting, this creates a problem of bias in the results. Okay, Mr. Chartier, please. Hello. As David was saying, I'm a science data scientist, and I have a cognitive software doctorate, and I also work in sociology. I think of myself as a sociologist, as well as a specialist in data, and I work in the industry. And if I put my data scientist hat on, and if I think about data cleaning, how to process large quantities of data from a data science point of view, all kinds of different issues come up. First of all, I agree, 80% of my time is spent on data processing. In data science, we often find that a data scientist's goal is to do machine learning, but really 80% of the work is simply pre-treating the data before you analyze it. We try to divide up the tasks. We sometimes try to give the cleaning and pre-treating work to junior data scientists, and then the senior scientists do the analysis. But sometimes it takes a senior data scientist to do the cleaning. So the three elements that I thought of, well, personally, I find that in industry, data is much more dirty, let's say, than in the academic world. So there's a lot less cleaning. This is very raw data in the industry, very ambiguous data. We don't always have the variable semantics for modeling. There are lots of coding errors and data drifting as well. So the name of a variable refers to different things over time. So let's say the variable on the socioeconomic status of an entity, it meant something different in 1980 versus today. So questions can change over time as well. Let's say an insurance company has a survey. Well, they might change their questionnaire questions over time, and we don't necessarily always, as data scientists, know the history of those changes. So this is quite a complicated issue. Another thing that I think is specific to the insurance industry, well, not only, but especially, is the fact that there's a lot of private confidential data. So when we're cleaning the data, we have to respect people's identity and personal data. For example, the medications that someone's taking. There's some information that we can't use in modeling. For example, someone's ethnicity, their gender. All kinds of ethical questions come up basically when we're doing this data cleaning. Because if we take away gender information, we might still have a lot of indirect information that might point to someone's gender, so we can infer the gender. So then we might ask ourselves, well, should we also remove those other data elements that might indicate someone's gender? So really, this becomes a very complicated issue. Another thing that I think is specific to Megadata is the fact that when we're cleaning the data, when we've got a giant corpus that we're working with, whether it's a text corpus or other types of data, we can't do it by hand. We always have to transfer our method to an algorithm. So we must conceptualize algorithms that will allow for us to express our goals when it comes to cleaning a given set of data. This brings up all kinds of other questions. And subjectivity issues and that kind of thing. So with Megadata, cleaning can't be done by hand. And so we have to come up with algorithms to do it for us. And that's another challenge. And that's an important issue. It's this algorithmic translation of our intentions. Great, thank you. Now, Mr. Fortin, please go ahead.
J'espère que tout le monde peut bien
Yes,
m'entendre.
I hope that everybody can hear me well.
Vous avez, comme Hélène et Jean-François, vous
So
avez
as
vraiment
Hélène
frappé
and Jean-François
les
have said,
enjeux, même à Statistique Canada, les taux de réponse.
they've touched on issues that come up even at StatsCan. It's quite a big problem.
La structure des données aussi,
Data structure as well.
C'est immense.
It's an immense issue.
Souvent, lorsqu'on cherche des données de d'autres,
when we're getting
comme
data
exemple, les postes de
from,
police,
for example, police
souvent,
records.
ils n'utilisent pas le même système.
They often
Donc,
don't use the same system as us.
De tout structurer ces données pour
So it's difficult to structure this data
les mêmes informations de chaque
and make
poste de
sure that
police.
we have coherent information.
Aussi, la normalisation
Also,
de
the standardization
disons,
of different kinds of data. For example, education.
Chaque province
Each province has its own primary and secondary system.
Au Canada n'est pas facile.
So it's difficult to
déjà,
work with this data. I don't want to just repeat what Hélène and Jean-François have already said. The issues that we see are very similar.
Que pour Jean-François et pour Hélène. Donc,
so, yes, that's it. Great, thank you. And now, Madame Da Sylva, please go ahead. Yes, hello, everyone. I totally agree with everything that's already been said. I was going to talk about the fact that the data from different sources are super heterogeneous. As Mr. Fortin was saying, it's quite a problem. And when you've got different sources, the problem compounds. One other thing I'd like to add. One important issue is the fact that when we're correcting and modifying and anonymizing data, it's important to keep a record of all of these operations that were done, to be transparent in the way that we have worked with the data and manipulated it, but also because sometimes we have to go back and undo certain operations. And that's a big challenge because it's often much more difficult to keep a trace of everything that's been done than simply to do the work. So that's the only thing that I wanted to add. I totally agree with what my other colleagues have said already. Great, thank you. Now, another point I'd like to touch on. There's probably one the standardization of data is probably a big element of this preparatory work. And sometimes we have, for example, the same variable, but it was collected in different ways using different methods. So one value, the value of this factor might be different, which creates a problem, as Jean-François was saying. And the problem of standardization is something that comes up a lot. For example, when we're trying to put different databases together. So what do you do about this issue? How do you deal with this issue of standardization of data? So let's go in the reverse order now. So Madame Da Sylva, we'll start with you. Great. I'm not sure. I'm not sure that I have this question. But anyway, I'll talk about this standardization that you've asked about. Standardization depends on the goals that we wish to meet, the way that we wish to use the data. This will determine the process that we undertake for cleaning the data and for standardizing the data. Let's say that in information sciences, there are operations that traditionally are used to create data. So for example, I teach a document indexing course. So ways that you can tag documents so that other people can then find them. And this creates data. I'm not talking about megadata here because I'm talking about small-scale manual operations. But when it comes to standardization, these issues that you've mentioned are very present in these processes that we do. And I think that it's related to large-scale data processing as well. I think it's relevant to that as well. So we have to, first of all, define what we call controlled vocabulary, which will limit the values of the data that we will connect. So for example, if we've got a document corpus talking about bikes and bicycles, we will use only one word, so either bike or bicycle. And whoever puts, for example, if we choose bicycle, then whoever puts bike, we will make sure that they put bicycle instead. So that's something that can help, having that kind of standardized vocabulary. This helps to clean up the mess a little bit and help everyone to choose the same values for the data. But there are also standardization methods for creating this controlled vocabulary. There are all kinds of methods that one could use to set this vocabulary. And there's also networks that can help you to use this vocabulary in indexing. So when we're talking about megadata, the issues are totally different because megadata is often generated automatically. There's no human intervention or participation. So I think we need to think about this, though. How can we standardize the values to try to limit the variations in the data? I see that Jean-François is nodding. I imagine that he's well aware of this issue. So that's it for me. That's my answer to that question. Thank you. Mr. Fortin.
Oui, donc à Statistique Canada, semblable à Madame Da Sylva.
We have similar issues to what Madame Da Sylva was talking about.
Harmoniser nos données, c'est important.
Trying to rationalize and standardize our data is very important.
Générale demande une question semblable à l'enquête sur la population active.
For example, when we're talking about the working population, we want to make sure that we're using the same vocabulary. When we're talking about people of working age versus people who are part of the labor force, it's not exactly the same thing. For example, we also have to think about what impact this will have when people then go query the data. At StatsCan, we try our best to make sure that people can have comparable data when they're doing different queries, and to make sure that everything is uniform. The census is our main and preferred method of query or source for our queries because it's standardized. So we try to use the census as a sort of comparison point. Mr. Chartier, please go ahead. Yes, regarding standardization, when we're working with megadata and are cleaning operations are done with algorithms, the standardization is done in a way that is created through an algorithm. We have to formalize the operation through an algorithm. So the cleaning is standardized in this sense, but that doesn't mean that there isn't any deviation that creeps in. Even with algorithms, if we try to put common routines in place for pre-treatment or pre-processing of data, there's still subjectivity that might creep in. For example, different algorithms can do the same operation. So choosing the algorithm is already a subjective choice. All algorithms have parameters. So initializing those parameters is also a subjective process. We never test all possible hypotheses and all possible parameters. So subjectivity comes in this way. And there are also other parameters that we have to choose. They're not always necessarily standardized. They might be random. And this can even creep in when we're doing coding. If we want to use a programming language, we have to choose a type of coding, a programming language. For example, float allows us to have set decimals. Or another one allows us to have 15 decimals. This might seem insignificant, choosing 7 versus 15 decimals, but the difference between an algorithm that uses one or the other can still affect the data. And this difference might be hidden in the algorithm, but it's still a subjective process. So yes, standardization is inherently subjective. And yes, the subjectivity always finds a way to creep in, unfortunately. Great, thank you. Is this subjectivity bigger and more present in the social sciences and humanities? Mr. Chartier, what do you think? Is there more subjectivity in social and sciences and humanities when it comes to data cleaning? Well, in social sciences, we work a lot with texts. We do a lot of analysis of speeches and textual data. So whether we're working with algorithms or doing qualitative analysis, we work a lot with texts. I think that text data leads to a lot more subjectivity. But really, this is a difficult question. I'd say that there is more subjectivity when we're analyzing texts in social sciences. So yes, maybe there's more subjectivity in this regard, because interpreting a text, well, there's often a lot of ambiguity in the language when you're doing so. So also, social sciences are a lot like insurance. It's a lot of sociology, a lot of social questions, analyzing people's behavior and habits. And then we have to make choices and categorize people socially, socioeconomic class, education, solvency, etc. So social classification is, well, actuaries also have prejudices and all kinds of biases. So I'd say yes. There's a lot of text analysis in social sciences because we're doing social classification.
Thank you for this interaction. We have Ms. Da Sylva raised her hand. I will pass the microphone on to her, and our colleagues as well. Yes, I'm sorry if I'm stealing Ms. Delorue's turn. I wanted to build on what Jean-François was saying. I think that, yes, there is more subjectivity in social and human sciences. If we take the discipline or the task, which is creating controlled vocabulary, you probably heard about thesaurus, that expression. They even have a dictionary in hard science, mathematics, biology, physics, and chemistry. Concepts have clear and well-established definitions. The limits of these concepts are much more consensual, much easier to determine. And we know in the building of thesaurus that building one in social sciences is more complicated and difficult because oftentimes people do not agree on the definition of basic concepts. If we try to define justice or freedom, interpretation, society, people won't necessarily agree on the definition of these concepts, how they relate to one another and how different they are. So if it's true, it is true for the definition of the concepts in the cleaning tasks. Thank you. I think we'll try to talk about this, about these differences between hard sciences and social sciences. I will pass the mic to Ms. Delerue. Yes, so there's a difference between various disciplines, but there's one thing that we have covered very quickly is that there still is a difference between the nature of data concerned if we talk about quantitative or qualitative data. In the case of quantitative data, there's always a reference basis, there's a reference point that becomes a comparison point. In the case of data collection, longitudinal data collection, that comparison point in general, as far as I'm concerned at least, is the similarity of questions, which brings me back to what Felix was saying. If we are in primary data collection, if we ask different questions, then the individual will answer differently on the scale required for this quantitative aspect in the questionnaire for primary data. And then the standardization is not subjective anymore. We are inventing things. If we're working with databases, I believe that we need to take into account the unit that is being analyzed in the research, especially in quantitative data. The analysis unit is defined by the variable we're trying to explain. So if we are at the individual level, we have a database. At the individual level, we have a database. At the country level, for example, that causes a problem. We will have to multiply, or anyways, start from an analysis unit that is common for both databases. As to the qualitative data, and I agree with what Lynn is saying, once again, how will we code a speech or a text versus concepts if we don't really have a clear definition of that concept? And that brings me back to what we addressed when we prepared the discussion table, the issue of epistemology and research method and research logic. So are we in induction or deduction? If we're in deduction, we are supposed to have clear concepts because we have defined these concepts, and we need to start coding as per what we've coded ourselves, as per literature, as defined by literature. And if we're, then there's another dimension. If we're in qualitative, then we're in definition of concepts. So standardization in that case doesn't cause any problem. If we're comparing things, we need to standardize because we cannot compare pigs and donkeys. So we have to find a common reference point. Great, thank you. That's wonderful. I'll start by inviting online participants and even the ones who are in the room to think about their questions. We have, well, in the next 10 minutes, I'll try to see if any people have questions, either here in the room or on Zoom. I'm going to ask a question. These are the questions that we had talked about. It's a general questions. After this first roundtable, if we wanted to define what data cleaning is, what are the steps of data cleaning? What does cleaning mean? Is it correcting the data? Is it to delete some of the data? Is it to filter out some of the data? Is it to put some values together? What is data cleaning? So I will once again start with Ms. Delerue. Ms. Delerue, we cannot hear you. Your microphone is off. Sorry. Yes, we addressed that at the preparation table. And now the notion of cleaning does depend on the discipline in which we are. We've realized that in management sciences, when there's a questionnaire, we need to determine where incomplete or unexisting answers may reside. So we clean data looking at the complete data in general. That's what we do in management. What was your other question? Yes, when we are working with databases, we need to try to see if we can complete these data, so to speak, or to delete them. Yeah, my experience, unfortunately, we have to delete the data. So in my view, cleaning data, when the data is incomplete, when we have questionnaires or databases with empty boxes, we cannot take into account the incomplete answer of that individual. I'm talking about the statistical individual here. We cannot take that into account. So cleaning means deleting some data. So deleting tasks or some of the tasks in cleaning according to, and data, complex data pose another problem. If other participants want or of the table want to talk about that, they're welcome. So once again, Mr. Chartier, what does data cleaning consist of? So in data science, cleaning is considered in a very incremental way. There are several steps, there are several operations required to prepare the data for modelizing and machine learning. So there are cleaning steps that have to be executed so that the data is prepared for modeling. So there are many algorithms that do not take some data in, that do not tolerate missing data. So we need to find a solution to complete the missing data. And that could hurt some of the researchers in social data, the techniques we use to complete the missing data, because in a perspective of predictive modeling, data cleaning goes on in the path of prediction. So ultimately a successful cleaning operation is an operation that increases the predictive value of the model. So if we increase the predictive value of what we're studying, does that mean we're increasing the quality of our model? That is an epistemological question. But in any case, oftentimes, cleaning serves the purposes of prediction. So what is cleaning? Is it reducing noise? As I said earlier, is it reducing the ambiguity of variables? Is it reducing the missing data, encoding errors or encoding data? Is it reducing data drift, as I said earlier? Yes. There is a debate in data science. Do our models have to be interpretable or not? That also affects the type of cleaning we will do in our data. If our predictive model does not need to be interpretable, we can apply cleaning techniques that are very sophisticated and that are difficult to interpret. So we don't necessarily want to tell a story with these text cleaning operations. But if we want to have data that can be interpreted, when we clean the text, it'll be important to replace this word by that word. For example, it'll be important to do such operations. If we do textual classification, we have to be able to interpret textual boxes or textual classes. But if interpretation is not necessary, or in the human interpretation of the model is not necessary, that opens the way to many other additional options for data cleaning that become available in that case. So data cleaning in data science often serves the purpose of prediction, and it depends on whether the data needs to be interpreted or not. I will take this opportunity to ask a question, a more direct question to you, because I know that you have vast experience in textual data preparation. What are the main problems with non-structured data? The main problem when working on unstructured data is to structure them. If we do not structure them, we cannot apply any quantitative technique or algorithm. So we need to find a way to model qualitative content in a quantitative way. And the standard way to do that with text is vectorial modeling. So we need to express textual content in the form of vectors, because algorithms manipulate vectors, which then lead to the possibility for machine learning. So we need to define, for example, the analysis unit. Is it a word? Is the basic unit of the analysis a word, or a word is a chain of characters separated by two spaces? In many cases, it's enough in a predictive perspective, but it's not necessarily interpretable for a human being. And after, we need to model relations between words, relationships between words, or the absence of relationships between words. But the goal is to mathematically translate the qualitative relationships. Thank you. So, Mr. Fortin, from Statistics Canada, what do you clean? What do you clean up? Well, what we do is similar to what Jean-François described. We prepare raw data so that they're usable for our users. So that means filling out empty boxes, correcting the flux, making sure the respondent followed the questionnaire. It's not often a digital problem, but oftentimes it's possible. So when it's on paper, it's more of a challenge. Of course, we use paper rarely nowadays, but we need to prepare derivative variables for our users who are a bit less tech-savvy than some of our analysts, but who still want to use our data. And often, we need to prepare predefined tables, predefined by Statistics Canada, so that we can display that information to Canadians. I'd like to take a step back with you, and then I'll pass the mic to Ms. Da Sylva on the cleaning matter. Earlier, not just you, but also I can remember who, Ms. Delerue, you raised the issue of the answer rates. from respondents, which is an issue in the amount of observable lines we have, but also it causes incomplete data when people don't answer all the questions. So what is your experience at Statistics Canada, and how do you think you will be able to resolve this issue in the future? That's a very good question. I don't think anyone in the world has the right answer to this question.
C'est toujours un problème, les taux de réponse.
The answer rate is also a problem. Oftentimes, what we observe is that somebody will begin, when they begin a questionnaire, they will finish it. That's what we often see. It doesn't matter how long the questionnaire is, most respondents will finish answering the questionnaire they started answering. The ones who don't finish answering the questionnaire, in that case, we are looking for a minimum of answers so that respondents go to a certain length of the questionnaire, then we consider that as a complete answer, and then we will fill out the empty spaces, if you will. As to the answer rate, that is diminishing, that's clear. In the 90s, we had 80% response rate. Now we're at 50%, which is a major challenge. So it's a bit higher than what Jean-François, a bit further than what Jean-François was saying, is we need to find models and we need to find a way to fill out what respondents left blank. So as he was saying, maybe people will have nightmares when they know what we need to do to fill out their empty answers. So yes, I have a question for you, Ms. Delerue. If others want to answer, they can raise their hand. By the way, somebody has already raised their hand in the room, or two hands raised about that question, so we will open the brackets here. I will still invite people to prepare their questions online as well. I have got 1 or 2 questions online on Zoom. Keep thinking about your questions and write them in the chat, or here, raise your hand if you're in the room. So let me get back to this point. The response rate is diminishing, and in a way, the methods for questionnaires in the past, representativity was very high. Now we are risking the validity of this method. There's a validity problem. So maybe at one point we'll be forced to find solutions, that is, keep filling out questionnaires, but how? I'm just asking now, are there data collection, unstructured data collection methods on the web or elsewhere which could do this task? And have you experimented with these in Statistics Canada? Yes, we've done some web scraping for Facebook or Instagram, but it's very difficult as a society when we use social media. Oftentimes, it's for the common good. We like to show the positive things from social media. We rarely publish something on Facebook or Instagram. So that causes a pretty wide bias when we use social media. We also look into apps. Everybody has their cell phone with them. So apps are very important to us. So we're looking into what we can do with apps, and sometimes maybe we send out notifications. For example, how do you feel today? For example, we can see if you're at the gym, and we can ask the person how they feel today. So we experiment with various things to see if there are other ways to obtain data. The other thing you said about unstructured data, we already do this, and we keep doing this more and more. We do not ask a question on income anymore. We obtain the tax income data. We get data on immigration, and more we try to get data or to collect data that is already available. And we draw a relationship between them and our data from social from social questionnaires or social studies. Yes, please raise your, yes. Ms. Baudry. Hi, everyone. Thank you for opening this horizon about various types of data. I have several questions. I've noted that Ms. Vidot, Mr. Fortin have not talked about attribution of data when there are empty boxes, missing data that could be added in questionnaires so that we don't lose the use of these questionnaires. But Ms. Vidot, maybe you don't have the quantity of data that allows you to do attribution of the source of data to have realistic results, while Statistics Canada represents the law, and represents the law, and we can collect enough data to do data attribution. But is there only a way? Can we only do? Can we only do data allocation or the source allocation or attribution when we have enough data? Because sometimes, people working with data are outside of their field of competence, and maybe, how can we do data source attribution with your algorithms? I'll start slowly because data source, the attribution of the source of data is something we do. We don't want to do it all the time because of the law. Yes, sometimes we're allowed to obtain more sensitive data. And, and we have the Act on Statistics on our end, but we need to respect the Privacy Act. Sorry, I don't know how that spells out in French, but we have not asked for permission. We don't always ask for permission to draw relationships between a study and another study. It's very rare that we will draw a relationship between the results of a study to the results of another study, or to do any data attribution between one another. So we often obtain or collect administrative data, as we call them, to fill the blanks. Or in the same study, we will do data imputation to fill the blanks. And we try to make predictions or expect what the predictions will be in our analyses. Just a question. The Act on Statistics prevents you from collecting data in a questionnaire to bring it in another study. The Act on Statistics allows us to collect data, but the Privacy Act does not allow us to combine the two sources. Thank you. I can build on this because we do a lot of crossover of data when we have missing data. So the methodological framework is prediction in data context. So any imputation of data that increases the predictive value of the model, well, not all, but in general, we consider them as justified. And in the industrial context, specific to insurance, we realize that historically, insurers ask too many questions for nothing, meaning that not most, but a lot of information is collected directly from clients, and we can infer these through other questions we've asked. We can infer these answers through other data we have from them. So we do a lot of imputation. For example, we have a client that's under 25. This, we know what diplomas he has. He has this history of reclamations. We have other information about them, allows us to, it's information we have. We don't need to ask so many other questions because we already have that information from them. And there are very simple imputation techniques. For example, having a median or a mean, oftentimes it's sufficient to improve the performance of the model. There are also near neighbor type techniques if you want to imputate a missing value to an individual. You take 5 individuals that have the closest profile to this one, you do an average, and you attribute him this value. It seems like a simple algorithm, but there are also social reasons for why such algorithm works. People share X, Y, and Z characteristics, also tend to share A, B, and C characteristics. So we use, the A, X, Y, and Z characteristics, and then we can attribute them A, B, and C characteristics as well. They're shared by common individuals. I will pass the microphone to Ms. Delerue because she raised her hand, and we'll move on to Ms. Da Sylva because I think she wanted to say something as well. Yes, I will build on what I said. I said delete. So in management science, when we collect data through a questionnaire, we have variables that are measured by several items. And if all items have not been answered to, we cannot invent the variable. But there's one very important thing when we have missing data. It is to know if it's because of chance or because of inaudible. So if we have a questionnaire and most people don't answer an item or a question, it's because there's a problem in the questionnaire. So that is another factor we need to look into when we do questionnaire pre-testing. That means that the missing data, where does it come from? Is it because people do not understand the question, etc.? Now, of course, we try, we also try not to delete this data and get rid of it, but it's complicated when we have a missing answer. It's more complicated, especially when we have small size samples. Ms. Da Sylva. Yes, the question of what it involves to clean, what it means, it depends what we do, what we want to do with the data. The decision to correct the data or not, and the way to correct the data. There's a major difference between the missing data and error data, error value. And I'd like to give you an example, something from my that I teach in my classes, in a class where students learn to clean data. I found a data set that is very appropriate. It is the result of the 1901 Canadian census. It's interesting because it's full of social data. It's vast enough, not too vast. Students can work with it. There's a lot of data in that data set. And what's interesting for me is that the data were entered manually at the time in 1901. It was then digitized over time. But there are many, many values that must be corrected. For example, there's a huge variation in answers to questions. A question ask them to express the relationship between the respondent and the head of the home. Is it the wife or the son or the daughter? And you'd be surprised by the amount of difference values and all different ways to write doctor, son, wife, spouse, all the spelling mistakes you could ever imagine. Everything is there. Same thing with race, religion. We have a bit of everything. So the question is how to correct this data. Well, it depends what we want to do with it. For example, if we want to know the scope of the answer given to the answer, we don't want to correct anything. We want to count that there are 360 ways to write a daughter, for example. If we want to have a good idea of the size of the households and who its members are, we want to apply a certain level of standardization. For example, if there's daughter, D-A-U-G-H-T-E-R, and there's no G, we can recognize this as the same word and standardize these. But sometimes it's more difficult because if in English daughter was abbreviated by DTR. We can consider it's daughter, but there can be things like TR, just TR. So we think it might be daughter without a D, but it reminds me of something that Jean-François Chartier mentioned earlier, is that sometimes there's subjectivity that comes into play. Are we in the process of, are we introducing errors or not errors, but are we introducing false data while we think we're correcting it?
If we don't want to interpret empty values, then we can just put them aside. But if we do want to count them, we have to see how many are empty, how many need to be interpreted. Perhaps you don't want to eliminate them. So that's just one example that I can give you of how the way we use the data depends on what our goals are. Yes, I totally agree with you. You've also answered some of the other questions that I had prepared already. So let's go forward now. Let's move on to the Zoom questions. I might take one or two, and then I will open the floor in the room to questions. First question, in social sciences, people are often frustrated. We usually want a certain result, and the secondary data contradicts our hypotheses, especially in developing countries. Sometimes results don't make any sense. What do we do? Is this a cleaning problem or a math problem? Madame Da Sylva, would you like to respond? Yes, sure. I'd say that I personally, as a professor, as a researcher, I think that in research, if we see data that contradicts our hypothesis, our only option is to report, well, this is our methodology, here are our findings, and they do not validate our hypothesis. You can try to explore and see if, is this a question of your methodology? And yes, it's very frustrating when the data contradicts what we think, but there might be a reason for it. There might be a very important lesson that we can learn from this contradiction. I have a colleague who was fighting to create a journal called the Journal of Interesting Negative Results. So that's quite cool, isn't it? Unfortunately, we can't say that the data is just wrong. These data were collected. We can try to explain the contradiction, but unfortunately, the data is usually right. Okay. Madame Delerue does a lot of research in this. You use a lot of epistemology. Do you have anything to add?
C'est vrai que quand on fait de la recherche, on est content quand on a.
I agree with Lyne. I know people feel very happy when everything works out very well. The data confirms our hypothesis, but research isn't always that. Sometimes we have findings that complicate our hypotheses or contradict them. So if the data was collected correctly, we must trust this data. We don't want to always find what we expect to find. That isn't realistic. I'd just like to add that this happens at StatsCan as well. We have internal investigations sometimes when the data shows us something that we're not expecting. As Lyne was saying, the data is right in the end. So we have to look at our methodology, other impacts to explain the phenomenon, but we try our best, but the data is right. Jean-François, yes, in data sciences, most models don't work. Most modeling projects we do fail. And yes, there's an epistemological risk here when we start insisting and trying to validate the model. In a business context, It's counterproductive, not only epistemologically, but also economically. Profit and epistemology go together. We want to increase a business's profits, so we need to have a good model. If we use a false model, we're not going to get good results. And this will hurt the company in the end. So we must be humble and accept and respect the data, really. Here's another question directly for you, Jean-François, from Zoom. You were talking about algorithms. And someone here says that they're very interested in cleaning algorithms. Do you have any examples of accessible and adaptable algorithms? Any examples that you can give? Well, let's say in text analysis, there's an algorithm that, well, I don't really know if it's called a cleaning algorithm, but I consider it so. It normalizes and qualifies words. A word can be written in different kinds of ways with different inflections and endings. And an algorithm could regroup, could categorize these words. For example, an algorithm that takes the last couple of letters off of the end of words in order to categorize them together. And this helps a lot because sometimes it's difficult to read words that might be missing a couple of letters at the end. And there are more complicated algorithms that could try to take the suffix off of a word. So there's an analysis algorithm in place to try to target and identify and take off the suffix of a word. And it's difficult to read words that have no suffixes. There are also more complicated algorithms that do linguistic analysis. And these algorithms try to take different inflections on a same word and categorize them grammatically, for example, singular, masculine, infinitive, etc. So those are some examples of cleaning algorithms. So different ways that you can write the same word. Great, thank you. Another question. Some questions have already been answered. So examples of missing data, examples of different steps of data cleaning. I think that these have already been answered. Here's a question that's a little bit more related to Mr. Fortin's work. Sorry, let me just pull it up. What leads to low response rates? Is it the time that it takes to fill out a questionnaire, its complexity, or the accessibility of information? So basically, why might there be a low response rate? Oh, that's another very complicated question. I don't really have the answer to it. There are different factors at play. StatsCan
une bonne réputation, pas qu'on n'a
has a
pas
good
une bonne réputation,
reputation.
mais avant, c'était vraiment la place pour des enquêtes.
We used to be the place for research.
Des
Now,
mille et des mille de gens qui demandent pour
there are
des enquêtes.
thousands of
Donc, les
people
gens
that
se
ask
tannent.
us for
Ils veulent plus
that send us
entendre des
requests
questions.
basically
On
for
trouve
data
souvent les gens n'ont
inquiry,
juste pas le
and
temps
often
à répondre. Puis nos
people
enquêtes
at
peuvent être quand
StatsCan
même
simply
assez
don't have time to respond.
laborieux.
And often it's the case with questionnaires. People just don't have enough time. People these days,
Pas que je sais que vous, la plupart de vous sont jeunes.
sorry, I know most of you are young. I don't want
de vous, là, mais
to be mean
souvent,
to you, but often
c'est la génération de
the younger generation
ici. Donc, tu sais,
is always
ça va
on,
vite, ça bouge
people are always
vite,
on their
puis, vous êtes
phones.
toujours
You guys
en
are
mouvement.
always
Donc, essayez de vous attraper,
moving,
c'est
you're
toujours
always moving on to the next thing very quickly, you're always on your phones. It's difficult
pour notre sample. Oh boy. Là j'essaie de rentrer dans les termes francophones qu'on utilise.
I'm trying to speak French here, but there are some words that I forget how you say in French. But basically with our sample and our frame, we usually use phone numbers and addresses, and it's not we don't really have a very good database of email addresses and cell phone numbers. Unfortunately, we use landlines and addresses. There are lots of factors that
dans ce cheminement-là, et aussi le coût.
On n'oublie
pas que le coût, c'est très cher.
Remember that this is all very, very expensive.
D'appeler des milliers,
it's expensive to call thousands of people, and we can no longer afford to go knock on everyone's doors. That's just too expensive now. It's something that we used to do a lot. We used to go door to door and ask people questions. And it's more likely that someone answers the door than answers the phone.
Un jeu qu'on joue avec, c'est tout le monde a, même si on a votre téléphone cellulaire.
And even if we have your cell phone number,
qui appelle. Donc, si c'est le gouvernement du
you can see who's calling. If it's StatsCan or the government, people often just don't pick up.
C'est un fait.
That's true. That's a fact.
Voilà.
So there you have it. When it comes to imputation, is there a rule that we must follow? I know that what is the most relevant technique for imputation? Well, there isn't really a hard and fast rule. People have different preferences. I'm starting to be repetitive, but when it comes to data science, we look at useful criteria validation. So anything that can help us improve the model's predictive capabilities is usually considered as being justified. And we test different versions, about 10, sometimes even hundreds of techniques. We play around with all kinds of different parameters. So no, there's no absolute rule. It depends on your goals. Great, thank you so much again. Thank you for having participated in this meeting. Thank you to the people who participated in person and online, and we'll see you in about 10 minutes. So thank you and have a good one, everyone. Great, thank you so much.